Today we're going to be going over geometry. We decided to go on the geometry lesson, and it deals with like area and volume, right? Area and volume. So I have a couple questions before we get started with anything. How many of you have landscaped before or have a backyard? I was the oldest, so I was always the one that had to help my dad, you know, so he needed to pull the weeds, we needed to make space for the garden or whatever for our rose bushes. So I didn't notice until even right now. I was like, hey, we used to find the area because we wanted that certain area just for rose bushes, and we did it without even knowing. So you go through and you do math even when you don't know. What we're gonna do today is you are gonna become a landscaper, and you're gonna find the area of things, and you're gonna see how much area you need for your area. Maybe you just want dirt in a certain, even though it's dirt already. Bricks in a certain section, you want a patio section, so you need cement for it. You need to figure out all these different areas. So that's what we're going to be working on today, but before we get there, we're going to do some vocabulary before we throw you out with the landscape.
We talked about regular figures previously. What's regular figures? So like square, we have, what else? Triangles and so forth. But now irregular, what is the irregular? What would that mean?
Not all sides are the same.
Not all sides are the same. What else would we
Is a circle a regular figure?
So, to find the area, we can find the area of a circle. We're working on, actually the concept today is to find the area. We have a formula, actually side square or L square. Area is 1/2 of base times height, and base times height. There is a formula pi r squared, okay? But today we're gonna, what if I have an irregular shape? What is, if this is a square and then I have a semicircle and a triangle? So we're gonna work on this, okay?
So that would be, for example, an example of an irregular figure. So those are kind of like our regular. We talked about how to find areas of rectangles, squares, triangles before, but now it's kind of putting them together, or maybe even taking it away. So, for example, I made the triangle here. Well, and I want to find the shaded portion, for example. Okay. Well, I know how to find areas of, for example, squares. Here we have another one. Semicircle, right? Circle, but it's how much of it? Half. Semi meaning half. So things like that. We're going to use our previous knowledge in order to find areas of certain figures that we're not accustomed to seeing or finding areas for. So what is the area of the big circle? So what did we get for the radius for the big circle? 2.7.
No, that's the diameter.
Divided by 2. Okay.
1.35. 1.35. I get 5 and 3, 2 and 3/8.
Okay. So that's the area of the big circle. But do we have this? We have the whole circle here?
No. So
No.
we take the half of it.
So now we want to find the semicircle, right?
That is 5.7. The area of the whole circle. 72.
72.
2.
What are your units?
Ah,
What are
units.
units?
Inches.
Inches?
Square.
Square.
Right, area. You have squares there. So we knew the area of circles, right? And then we were able to figure out semicircles because it's just half of that. And then we saw, okay, big circle, take away the big semicircle, take away the smaller semicircle. That would be left with the C. All right, so then you would follow the same procedure, break it up into shapes that you know. So for example, B, what shapes do we have here? Rectangles. Are they all the same? No. So you need to measure the ones that are different and find areas for those, okay? You would do the same thing for C and D, okay? And we give you guys time to do
The
that.
students always ask for real application of area. Where or when do I have to find the area? And you know, this is a good opportunity. What if I'm reading this? This is 98 cents. And I read this 16 inches. Okay. So then, how many bricks, let's say your dad asked you to help in the landscaping, right? So how many bricks you need? Okay, so after we got the area, okay, which is, the final was 2.07 square inches. Now we have to figure out, now with these letters talk with the students, okay, which dimension, because if you see the brick, this actually, they are talking of 3 dimensions. The length, the width, the height. Do I need the height to find the area? No, then you say, okay, you know what, now I can erase this because I don't need it. Do I have to find the area of flowers? Yes, but for example this, I find this information. It's a 297. Then densely leaf every garden blooms in dry season, plant in full sun to partial shade, grows 18 inches tall and 18 inches wide. Okay, if the student or if somebody wants to landscape and they read this information, what information is this 6 inches pot? What this means? And maybe we can ask the students because they can figure out like, oh, this is like how much it covers. No, you know what? This is the size of the plant. If you go to Home Depot, no, you're gonna find plants in a small pot or in a big pot. Maybe you can find the same plant, but what is the difference? This is gonna be more expensive because maybe this has been there for 1 year. It's bigger. Okay, so if you want like a palm tree, maybe you have to wait 3 years to get some tree that you want a shadow. Okay, you have to wait like 3 or 4 years to get shadow. Or if you buy a big plant instead of 6 inches pot, okay, that's the difference in price. Now, what we want for this project is this information. This plant can grow 18 inches tall, but also 18 inches wide. So even for the plants, we can save money and try, okay, if this grows 18 inches wide, that means that each plant is gonna grow around like 18 inches. So it's gonna make like a circle. That way, when I do the design, I can say, okay, I can put one, and this is important, like, okay, if this is 18, I'm not gonna put it 18 inches from the edge. I wanna put it 9 inches from the edge. So then, okay, how many plants do I have to buy, like to cover, let's say, if this was the L or the I? Okay. This gives us a lot of information also, like the rocks, we mentioned the rocks. Yeah, some people, they say, no, I'm gonna work, like I'm gonna landscape. I don't need math. You know what? You need math.
Yeah, this is a really good example where they see geometry being applied in a career that is, I mean, basically it's all geometry. Most of it. So